My name is Mr. Emmanuel Omori. We're going to be doing mathematics today, and the topic we'll be handling today is circle theorems. And like the name, you can see the name circle, so it means you know that it has to do with circles. It is a set of theorems or rules. Circle theorem just simply means the rules or set of theorems that tell you how an angle relates to another angle within a circle. Okay, so let's say you have a circle like this, and then you have something inside the circle. So you have an angle here, you have an angle here. So you have a rule that tells you or shows you the relationship between this angle and this angle. So a couple of angles that are in the circle. So circle theorem is simply set of rules or theorems that show us relationships or tell us the relationships between different angles and lines within a circle. Now, when we are doing circle theorem, it's important you understand circles itself because it is a topic that has to do with circles. And of course, first thing you know that a circle must have a center. So a circle must have a center. And usually, if you're writing WAEC, you go to past questions, you know, you're going to see anywhere you see 0 written, know that that is where the center is. Anywhere you see 0 written, and this is important because you see when you go to past question papers, where you see 0 does not look like that is where the center is, because sometimes it could be typographical error. But how you identify a center is not necessarily because it looks like it is at the center. It is where 0 is. So where you see 0 in the question, know that that is where the center is. So even if you see 0 here in this diagram, of course, you can see it doesn't look like center, but if I see 0 there, that tells me that is where the center is. Then I will assume it's a typographical error. But anywhere you see 0, that's where the center is. So the 0 actually identifies where the center is. And why is that important? Because in circle theorem and circle geometry, there are lots of lines. There are some of the lines that will pass through the center, and there are some that won't pass through the center. So, and where any line, of course, you know any line that moves from the circumference, first of all, you know that this line that goes around the circle is circumference. And any line that starts from the circumference and then passes through the center and then goes back to the circumference, if it passes through the center where the 0 is, that line is a diameter. Now, even if it doesn't look like that's where the center is, even if in your diagram it looks like this is where the center is, you know, this is where the 0 is, and it doesn't look like that is the center. Any line that passes through where the 0 is a diameter. So you take note of that as well. So a diameter, like we know, is a line that moves from the circumference, passes through the center, and then goes back to the circumference. But we also have other lines that do not pass through the center. So if we have another line that starts from circumference, but it doesn't pass through the center and then gets back to the circumference, that line is called a chord. Always ensure that you can identify your diameter in a circle and you can identify your chord. Okay? You can identify your diameter, you know, with the help of the 0, and then you can identify the chord. Any chord that's not passing through 0 is, any line that is not passing through the 0 is a chord. Okay, so this is a chord, and then this is a diameter. Okay, this is a chord, and then this is a diameter. And if I draw a line like this, it doesn't pass through the center, so that's a diameter. It doesn't pass through the center, so that's a chord. Okay, so any line that is not passing through the center, but it starts from the circumference and ends up in the circumference without passing through the center, that line is called a chord. Okay. Now, it's important to know that diameters and chord form angles. Okay. The diameters and chords within a circle can form angles. That's why I say it's important you can identify diameter. It's important you can identify the chords in the circle. Diameter you can know using the wherever it says 0. Okay. In the center, you know that that is where the center is. Any line that passes through is a diameter. And then if any line doesn't pass through, is a chord. Now, a chord, for example, this chord can form, and this is a circle, and then this is my center, and then this is my 0. Okay, all right. This is a chord. This chord can form an angle. It can form an angle at the center. Okay. Now, this chord starts from this point, call it point A, and then ends at this point, call it point B. So the chord starts from point A to point B. So we can call the chord AB. Okay, so this is chord AB. It starts from point A, ends at point B. Chord AB can form an angle. It can form an angle at the center. How does a chord form an angle at the center? A line comes from one end of the chord to the center, and then another line comes from the other end of the chord and meets at the center. So where the two lines meet, that is where an angle is formed by this chord AB. So this angle A, if I call this angle A, that means this angle A is formed by chord AB. So AB has just formed a chord at the center. So how does it form a chord? Two lines will come from the ends of the chord and meet at the center. Where they meet, that's where the angle is formed. That's an angle formed by the center. Angle formed at the center by chord AB. Now this chord AB can also form another angle. It can form an angle this time on the circumference. And the same way, so from one end of the chord, the line will come and they meet and touch the circumference. And another line from the other end of the chord will come and then also meet with the other line at the circumference. Where the two lines meet, that is the angle formed by chord AB at the circumference. So this is an angle formed at the circumference. You can call the angle B or any letter of your choice. Okay, so this chord, what has happened? This chord has formed an angle at the center, angle A. This chord has formed an angle at the circumference, angle B. Note that the chord is forming an angle at the center. It is not this angle that you call A. Okay, it is where the chord, this angle below, it's the angle formed by the chord. Okay, now that is very important. So this is angle formed at the center, and this is angle formed at the circumference. Now the chord can form many angles. That's why in circle geometry, you're going to see circle, you see circle and see several lines that you get yourself confused. That's why, like I said, it's important you identify chord, because I'm going to show you there are many chords actually here. Now this chord again can form another angle if it, depending on the question, can still form another angle at the circumference. You see that? So how does a chord form an angle at circumference? One line will come from one end of the chord and then go straight and touch the circumference. Then the second line comes at the other end, from the other end of the chord, and goes straight and forms and touches the circumference. Where the two lines meet, that is another angle formed by this chord AB. So this chord AB has been able to form an angle A, an angle B, and angle C. As a matter of fact, it can form as many angles as possible. The chord AB can still form another angle down. And how does it form an angle? A line will come from one end of the chord, and another line will come from the other end of the chord, and they meet. Where they meet, that's another angle formed by the chord. So a chord can form as many angles as possible, and as many angles as possible. This angle, they are all formed by the same chord. Good. Now, even the diameter can form an angle as well. It's not just the chord. Remember, diameter is a line that passes from the circumference through the center and then goes back to the circumference. Now, I can call this diameter AB. AB. Now, this diameter can also form an angle at circumference. So, how does a chord or diameter form an angle? One line will be drawn from one end of the diameter and where it touches the circumference. Another line is drawn from the other end of the diameter where the two lines meet. That is the angle formed by the diameter. And of course, you know that this angle, the diameter can also form an angle here, another angle here, and so on and so forth. Are we there? So whether chord or diameter can form an angle at the center and at the circumference. The chord can form an angle at the center and at the circumference. Diameter can form an angle at the circumference. Now, in circle theorem, I'm just going to talk about, I'll just mention two theorems and then we will look at questions. Okay, we'll look at some WAEC questions on circle theorems and solve them. Okay, now the first theorem I want to, and I'll give you the theorems in no particular order. But this first theorem, the first theorem that I want to tell you is that it states that the angle formed at the center is twice that formed at the circumference. Theorem 1, paraphrase, it just simply means the angle formed at the center is 2 times the angle formed at circumference. So if I have a circle like this, and this is my center with O. Remember, the center, usually O is written at the center. Okay, then I have a chord like this. Now I can give my chord a name, AB. I can give it a name, AB. Okay, so I have a circle and then I have a chord. A chord is a line that moves from circumference to circumference without passing through the center. Now this chord can form an angle at the center. And then that same chord can form an angle at the circumference. Understand that the lines must touch or meet at the circumference. Okay, so where they meet, that's where the angle is formed. So this chord AB has formed an angle at the center. Maybe call it A. And then from the angle at the circumference, call it B. Okay. The first theorem simply tells you that the angle at the center is 2 times that at the circumference. It means angle at the center, which is A, is 2 times, that means equals to 2 times angle at the circumference, B. So the first theorem simply tells you angle at the center, which is A, is equal to angle 2 times the angle formed at the circumference. So that's why I told you that Circle Theorem tells us relationships between angles within a circle. Like this one now, angle at the center, the theorem says angle at the center is twice that at the circumference. Angle at the center is twice at the circumference. But usually, we may, instead of writing A, we decide to write it like this as well. This A is, look at A, this is O, and this is B. A, O, B. This angle is A, O, B. I can call it angle A, O, B instead of calling it A. Angle A, O, B. Where the A is the angle at the middle one, the O. The A is at the O. The A is not at the, this angle is not at the A. The angle is not at the B. The angle is at O. Okay, so I can call it angle A, O, B. Where the angle is usually at the middle. Okay, now if we don't use it like this, we can decide to use it, put it like this. Angle AOB. So angle AOB simply means the angle at O, which is A, okay, is equal to 2 times the angle at B. Now, here has to have, maybe let's call it C. Call it A here, C here, B here. So this B, now instead of calling B, I can also call it, this is ACB, and B is at C. So that means C will be at the middle. ACB. So instead of writing B, I can as well write ACB with the sign of an angle here. Okay, so you have angle at the center. So angle at the center is angle AOB, and angle at the circumference is angle ACB. So the theorem, first theorem says angle at the center is twice that at the circumference. What that means is that if here is 100, and the law says, or the theorem states, that angle at the center is twice that at the circumference, that means angle at the center is twice that at the circumference. That means angle at the center, which is AOB, is 2 times angle at the circumference, which is ACB. And I know AOB is 100, so I can put 100 equal to 2 times ACB. Okay? And so since I'm looking for ACB, I'm looking for B, this angle here is also called ACB, or simply B. Okay? If I'm looking for B, I can divide both sides by 2, and that gives me 50 degree equal to ACB. That means angle at the circumference, ACB, is actually 50 degree. So the first theorem is telling us that the angle at the center is always 2 times the angle at the circumference. That means it's twice bigger than the angle at the circumference. Okay. Now I needed to know how to use this A or B stuff. Okay, because that's also important. So that is first theorem. That's what it means. You don't have to cram the theorems. You just need to know it and then know how to apply it. Application is the most important thing. Okay. So just know that the first theorem is a theorem in circle geometry that states that angle at the center is twice that at the circumference. Okay. Now the second theorem I'd like us to look at. Okay, let's look. There's another theorem that tells us that if you have a cyclic quadrilateral, I'm sure you can see cyclic quadrilateral. A quadrilateral is any shape, four-sided polygon. Any shape that has 4 sides is a quadrilateral. Okay, so cyclic quadrilateral simply is a quadrilateral that is inside a circle. So any quadrilateral that's found within a circle is cyclic quadrilateral. So if we have a cyclic quadrilateral like this, where the ends of the quadrilateral must be touching the circumference of the circle, otherwise we don't call it cyclic quadrilateral. The ends of the quadrilateral must be touching the circumference of the circle. So this is a quadrilateral because it has 4 sides and it is within a circle. So this is a cyclic quadrilateral. Now we have a theorem that tells us that now in this quadrilateral, you can see this side is opposite to this side. So if I call here A and I call here B, A is opposite to B. And then if I call here, you can also observe that this side is opposite to this side. So if I call here C, if I call here C, I can call here D, that will mean that C is opposite to D. That will mean that C is opposite to D. So if you look at this, you discover that A is opposite to B and D opposite to C. Now we have another theorem in circle geometry that tells us that opposite angles of a cyclic quadrilateral is equal to sum up to 180 degrees. Opposite angles of a cyclic quadrilateral add up to 180. That means opposite angles of a cyclic quadrilateral are supplementary. So it means that A and B, because they are opposites, it means that they will add up to give you 180 degrees. So what that means is that A plus B is actually equals to 180 degrees. And because they are opposite, they are angles in a cyclic quadrilateral that are opposite each other. So angles in a cyclic quadrilateral that are opposite each other will always add up to give you 180. And two angles that add up to give you 180, we say they are supplementary. We say they are supplementary. If two angles add up to give you 90, we say they are complementary. But if they add up to give you 180, we say they are supplementary. So opposite angles of a cyclic quadrilateral are supplementary. So that also means C and D, because they are opposite, so it means that C plus D is also 180 degrees. So anytime you see a circle and then you see a cyclic quadrilateral inside a circle, understand that the opposite angles are always supplementary. If you look at this diagram that is here, I'm sure you have to look, you will see a cyclic quadrilateral as well. For example, you can see this. This is a quadrilateral. It's a circle. That's a circle. That's a quadrilateral, cyclic quadrilateral. Okay. You can also see another cyclic quadrilateral. That's another cyclic quadrilateral. Okay. So you see, the thing about circle geometry, there are a lot of lines. So you have to look very carefully to know and identify whether there's a quadrilateral at all or not. So this is a cyclic quadrilateral. This is also another cyclic quadrilateral. Okay, that's a quadrilateral four-sided shape that is inside a circle and where the ends touch the circumference. It's a cyclic quadrilateral. So that means that because the cyclic quadrilateral, if here is T, that will mean that because this is also a cyclic quadrilateral, that will mean that B plus T also equals 180 degrees. They are supplementary. B and T are supplementary. That will also mean that because this is a cyclic quadrilateral also, that can also mean T plus C is also equals to 180 degrees. Anytime you identify quadrilateral, a cyclic quadrilateral, understand that opposite angles. Now, opposite angles are always supplementary. Now, you can see another quadrilateral here. But this is not a cyclic quadrilateral. So you have to be careful in identifying your quadrilateral. Okay, you have to carefully identify your quadrilateral. This is a quadrilateral, but it is not a cyclic quadrilateral. Why? Because all the ends of the quadrilateral are not, this side touches the circumference, this side touches the circumference, this end of the quadrilateral touches the circumference, but this side is not touching the circumference. This side is at the center. It doesn't reach the circumference. So if I have a circle like this, and I have something like this inside the circle, and a quadrilateral inside the circle. So even though this is a quadrilateral inside the circle, but this law does not apply because this quadrilateral is not touching the circumference. This end 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 is also not touching the circumference. Now, even if you have 3, this law still does not apply in this case because, all right, here touches the circumference, no doubt. Here touches the circumference. Here touches the circumference. Here touches the circumference. But this end is not touching the circumference. So this law does not apply. So you cannot say opposite angles of a cyclic quadrilateral in this case are supplementary. Because here touches the circumference, here touches the circumference, here touches the circumference, but here is not touching the circumference. So we can't say opposite angles are supplementary. So it is not all quadrilaterals that you find inside a circle that this law applies to. It's only those quadrilaterals where their ends touch the circumference of the circle. So now we have seen 2 theorems. First is that the angle at the center is twice that of the circumference, which we have seen. Angle at the center is twice that of the circumference. And then we have also seen opposite angles of the cyclic quadrilateral are supplementary. If I call here A, and I call here B, and I call here C, and I call here D, that will mean my C is B angle BAD. My C is angle B, that's another way of writing my C, DAD, plus D is, look at D here, so D is BCD. BCD. So you have BCD. Okay? My D, look at D, is BCD, where the angle is at the middle. So angle BCD. So I can write this D as this, I can write this C as this, then equal to 180 degree. Okay, so you can write it this way, where the angle is at the middle. Here the angle is at C, which is at C. Here the angle is at A, which is at A. So this angle can be written like this. That's this angle can be written like this. This angle can be written like this. Then 180. Okay. So now, so we have seen two theorems. Now, like I say, just know it. Okay. You don't have to cram it. And nobody will tell you to state the theorem. Your work is to know the theorem and then know how to apply it. Now we introduce one more theorem and then we'll look at questions, past questions. Now, the next theorem I want to show you is this theorem, for example. It is a circle, so you have, it is a center that carries O. A center usually has O there. Even if the center doesn't look like that is the center, if you see O, that tells you that is the center of the circle. Okay, so this is the center. And then the diameter is a line that moves from the circumference and passes through the center and goes back to the circumference. Okay, so now this is a diameter. Why? Because it's passing through the center. If it wasn't passing through the center, I would have called it chord. Okay, so this is the diameter. All right. Now, of course, you know that the diameter divides the circle into two equal parts, and those parts are called semicircle. So this is a semicircle. There's a semicircle here. This is a semicircle, and this is also a semicircle. Semicircle. Okay, good. Now, this theorem tells us that an angle formed in a semicircle is always equal to 90 degrees. So this is a diameter. Call it AB. I can call it any thing I choose. Call it AB. That's a diameter. If this diameter forms an angle at the circumference, if a diameter forms an angle at the circumference, how does a diameter form an angle? A line will start from one end of the diameter and then get to the circumference. And then another line will start from the other end of the line of the diameter and then go to the circumference where the two lines meet. That is the angle formed by this diameter. So this diameter has formed an angle now, which is here at the circumference. Good. So the theorem tells us that any angle that a diameter forms at the circumference, that angle is always 90 degrees. Or we can just simply say it's a right angle. Of course, you know that right angle means 90 degrees. A right angle is always equal to 90 degrees. Right angle is 90. So a diameter, so the law can put it this way, which means angle in a semicircle is right angle. All that simply means is that any angle that the chord makes at the circumference, that angle is always 90 degrees. That means the angle is a right angle. So far we've talked about three. So you must know that this is diameter. You must know that the angle is made by a diameter, not a chord. Because the thing is that in circle geometry, you always have circle and you have plenty lines inside the circle. And you may not even be able to identify, you may make a mistake to identify which is chord, which is diameter and all that. Now, if you look at this one, for example, you can see there are plenty lines. Okay, there are plenty lines. Okay, now if I ask you, identify the chord, a chord, you know, you may just, because I've used this one as an example, you may say the only chord there is AB, but that's actually not the only chord there. A chord is a line that moves from circumference to pass to the center. So you can see that B and C, that is BC, is also a chord. A, if I call here, let me call here is AB, and let me call here B, and let me call this NC. Let me call this NT, capital T. Okay, call this N capital T. Now, this is capital T. Now, take note like this. BT is a chord because it's a line and it's not passing to the center. AT is a chord because it's a line and it's not passing to the center. AB is a chord, just like AC is a chord. CB is a chord. B, let me call here D since I already have B here. Okay, so CD is a chord, BD is a chord. So they are all chords, and all of them, most of these chords, if you see, they are formed angle at the center, angle at the circumference. Okay, so now we have looked at these three theorems, which is first, angle at the center is twice that of the circumference. The second one is angles, opposite angles in a cyclic quadrilateral are supplementary. And then we have also seen that angles formed in a semicircle is a right angle, meaning angle formed by a diameter, okay, by diameter at the circumference is 90 degrees. All right, with these three theorems, let's look at some past questions, that touch these theorems. Okay, so we're going to be taking this question. This is a WAEC question 2018, number 4. We are given a diagram where we are told that in the diagram QOS, you can see QOS. So QOS is a diameter. QOS the diameter. And then we are also told angle RQS. See, RQS. That's the angle at Q. RQS. RQS is X. Okay, the angle is always at the middle one. RQX. S is X. And we're also given the angle is at the middle alphabet. Okay, so QST is 3x plus 15. And we are told to find the value of X. Now, in this question, first of all, I can see a diameter, and looking at it, I know that the diameter has formed an angle at the circumference. So now, this is the diameter, and this diameter has formed an angle at the circumference. How do I know? From this end of the diameter, there's a line that comes to the circumference. And then from this end of the diameter, there's another line that comes to the circumference. Where the two lines meet is the angle formed by the diameter. So the angle this is the angle that is formed by the diameter. And one of the theorem has told us that any angle the diameter forms at the circumference, that angle is actually 90 degrees. So the law puts it this way and say angles formed in a semicircle is 90 degrees. So this I have seen is 90 degrees. So now you see, nobody's going to tell you this is 90 degrees. You have to know the theorems and look at the diagram and know what the theorem, what here is. So I have looked and I see that this is the diameter. The diameter forms an angle at circumference. So I know here is 90 degrees. So first of all, let me establish the fact that here is 90 degrees. So I just simply say QRS. Q, angle QRS is equal to 90 degrees. QRS is equal to 90 degrees. Why? The reason is what you put in the bracket. Your reason is always important. You must put your reason for this statement inside the bracket. So what's our reason here? This is angle in a semicircle. Angle in a semicircle. The theorem says angle in a semicircle is 90 degrees. So I can say that this is 90 degrees. Why? Because that's the angle in a semicircle. That means that's the angle that the diameter forms at the center. So now I've established that this angle is 90 degrees. Now the question says I should find the value of X. Now, see X here, see X here. Now looking at this question, I would like to use the sum of angles in a triangle. Why? Because I am seeing a triangle. This is a triangle here. This QSR is a triangle. And of course, we know that sum of angles in a triangle is 180. That means that this angle plus this angle plus this angle, not that the angle inside the triangle, not the angle outside the triangle. This angle is not inside the triangle. So the angles that add up to give us 180 is this angle plus this angle plus this angle. They add up to give us 180. So that means I can say that this angle plus this angle plus this angle add up to give us 180. Now, but that cannot give me X. Why? Because I don't know this angle. This angle is given to me as X, and I know using the theorem that this is 90, but I don't know what X is. So now I'm changing. So to get what here is now, I have to now apply sum of angles on a straight line. Why? You can see this is a straight line. Sum of angles on a straight line tells us that every time you have a straight line and you have angles that are together, let's say this angle, and then together with this angle, they are together on the same straight line. Two angles that are together on the same straight line. This angle is on this straight line. This angle too is on this straight line, and together. Two angles that are together on the same straight line, they are always equal to 180. So that means that B plus A is 180 degrees. Now, so I'm going to apply that here because I have seen this is a straight line. And then this angle here and this angle are together on a straight line. So what that tells me is that this angle here and this angle here are equal to 180 degrees because they are angles on a straight line. So that means I can say that this angle here, how do I write this angle? QSR. Angle QSR. QSR, that's this angle. Plus this angle here, how do I write this angle? QST. because angle is outward. QST. So QST. QST. So QSR plus QST equals 180. What is your reason? When you make a statement, you put the reason in the bracket. Very important. You can't make a statement without giving us the reason in the bracket. So if I say this angle plus this angle equals to 180 degree, my reason is sum of angles on a straight line. Sum of angles on a straight line. Remember I said angles, we don't have to spell angles. We can just simply put this symbol and put S. Okay, sum of angles on a straight line. Now if you see, this angle is what I'm looking for. I'm looking for this angle first. Now to get this angle, I have to make it stand alone. And that angle is QSR. So I want QSR to stand alone. Let me bring down QSR. Angle QST was given to me. QST was given to me, which is this angle, which is 3x plus 15. That's the angle equal to 180. Okay. All right. So this angle, therefore, because I want it to stay alone, will stay here. Then 180. This one goes over and becomes minus 15. And then this one goes over, becomes minus 3x. Now 15, take away 180 minus 15. So angle QSR equals, so 180, take away 15. 0 that is 10. 10 minus that, 5. 7 minus this, 6. And then you have 1, 6, 5. Then minus 3x. So what that means is that our QSR is 165 minus 3x. Now where's our QSR? Remember, QSR, meaning this place. So here is actually 165 minus 3x. Now I now know this angle, okay? Even though there is x, I can now apply some angles in a triangle. And this is my triangle. And the angles inside the triangle are this, and this. So I can now use some angles in the triangle to find my x. So that means I'm going to say this angle, which is angle, what do I call this angle? I can call this angle, okay, let me use x plus, here, remember, we use the theorem to know what here is, okay, which is 90 degree. 90 degree. And then plus here, plus 165 minus 3x, all equals 180 degree. Why? Why are you making these statements? You put your reason inside the bracket. Because they are sum of angles in a triangle. I can decide to put this symbol to show that triangle. I don't have to spell triangle. So now, so let's find out x. So I have x plus 90 degree plus, open the bracket, I will have 165 minus 3x equals 180 degree. So bringing like terms together, this is x here minus 3x equals to 180. 180, this goes over to the side, you have minus 165. If 90 goes over to the side, you have minus 90 degree. So this is left alone here, and the minus divide minus plus. So if I divide 2 here, 2 here 1, 2 here maybe 3, remember 1. 2 into 5, 2 into 15, you have 7. Remember 1.5. So what you have here is 37.5 degree. Okay, so our answer therefore is 37.5 degree. 2 into 7 is 3, remember 1, carry the 1, join to 5, you have 15. 2 into 15 is 7, remember 1, add point and add 0 to the 1, you have 10, and 2 into that 10 is 5. So this is our answer. So we have found our x, that is the value of x. Okay, we're going to be doing another question, another Y question, this time 1996, number 10, where we are given this diagram, and then we are asked to find the value of x, y, and z. So this is x here. X is this angle, that's the one below, and y is this one here at the circumference, and z is this one at the center but on top. Okay, so we're looking for x, y, and z. Naturally, there are two ways I can solve this. I can decide to use I can easily get y. I can use the other law, supplementary. The law that says opposite angles of a cyclic quadrilateral are supplementary. I can use that to get y. I can actually start from there. I can use that to get y. Because I hope you can see a cyclic quadrilateral there. We say cyclic quadrilateral, if you see a four-sided shape inside the circle, and this is a four-sided shape, you can see this is a quadrilateral, a four-sided shape. You can see it. It's inside the circle. So it's a cyclic quadrilateral, and the law applies because all the ends of the quadrilateral are all touching the circumference. And we told you that this is a quadrilateral too, but this one is not considered. This law doesn't apply. Opposite angle of a cyclic quadrilateral as supplementary does not apply because this end is not touching the circle. So not all quadrilaterals in the circle not all the quadrilaterals in the circle you can apply those laws. So now I've seen a quadrilateral in a circle, and that means, and the law says if I see a quadrilateral, opposite angles are supplementary, meaning this angle and this angle, they are the opposite angles. This angle is opposite this angle, so they are supplementary. So that means this angle and this angle equals 180. Remember, supplementary angles are angles that equal 180. So I could just simply say that y equals 106 degree. Why? Remember, I told you when you make a statement, you have to tell us the reason why. Okay, because we want to know where that is coming from. We want to know which theorem. It's in your mind to make that. Okay, so this is simply supplementary angles. Supplementary angles. So y plus, rather, not y equals to, y plus 126 equals 180 degree. Supplementary angles. Y plus 126 equals 180 because they are opposite angles of a cyclic quadrilateral. So I can find y using this. So I can say y equals 180 degree. This goes over, you have 126. So I have y is equal to 180 minus 126. This is, take 1 here, put here 10, that is 4. This is 7 minus that is 5. So I have 54 degree. That's my y. I found y. Now I found y. Now I can find anyone. Remember, we also have the law that says an angle at the center is twice that at the circumference. The angle at the center is twice that at the circumference. Now look at the chord. Please take note. A chord. I have chord AB here. I also have chord AD. AD is a chord. DC is a chord. BC is a chord. Remember, a chord is a line that starts from circumference to circumference, but it's not passing through the center. So ABC is a chord. BA is a chord. AD is a chord. DC is a chord. Now, but take note of this one. AC is also a chord. There are chords that we don't know, we mustn't put the lines. This is a chord. And I don't all have to bring out the line for you to know it's a chord. So AC is a chord. So when you see from A, you see a point A on the circumference, another point C on the circumference. From A to C, the straight line from A to C is a chord because there's no way this line can pass to the center. The center is above them. So this is a chord, even if I do not bring out the line. Good. So now I have found my y using angles of the center, opposite angles of a cyclic quadrilateral supplementary. Good. That has helped me to find y. Now I can choose to find x or find z. The choice is yours. But let me find x, for example. So this is a chord. This chord makes an angle at the center. How? You see two lines from the ends of the chord go and meet at the center and form this angle x. So we can say that x is an angle formed by chord AC. So chord AC forms angle x. Okay, we have said that how do chords form angle? Just take lines from the ends of the chord, and when they meet at the center, that angle formed at the center is said to be formed by this chord. Now this chord has also formed another angle, but this time at the circumference. Now take two lines from the ends of the chord and then take them to the circumference. Where they meet is another angle formed by this same chord AC. So that means that this chord AC has formed an angle x at the center. This same chord AC has formed an angle y at the circumference. So now I have an angle formed at the circumference and I have an angle formed at the center. So that brings me to that other law that says an angle at the center is 2 times the angle at the circumference. So that means the angle at the center, in this case, is x. Angle at the center is x, is equal to 2 times the angle formed at the circumference. That is y. Angle at the center is 2 times the angle formed at the circumference. Okay, so remember I said if you make a statement, you always put your reason in bracket. Okay, your solving is not complete without giving us your reasons. So here I can say angles at the center. Angle at the center is twice that formed at the circumference. Angle at the center is twice that formed at the circumference. Okay, so that's my reason. So when I say x equal to 2 times y, why am I making this statement? Angles at the center is twice that formed at the circumference. Now x, I don't know, so I bring down my x, and then 2 times y. I didn't know my y, but I found it in my first calculation, which is 54. This is another question, y question, 2014, number 41. Now we're given another question, which is determine the value of m in the diagram. Now we can see this diagram here. Okay, and here is m. The angle here is m, and then the angle here is 80, and no angle is here, and no angle is here. No angle is here, no angle is here, and here is m, here is 80, and we have to find m. Now you're going to observe that this angle has 2 strokes. This line has 2 strokes here and 2 strokes here. Okay, which means that the line here is equal to this line here. This line has the same length as this line, this line. And then here you have 1 stroke. This line has 1 stroke, so the line has 1 stroke, meaning that the length of this line equals the length of this line. Now, since they have given us strokes here, that seems to mean that we may have to divide the shape into 2, because from B, I would love to divide the shape from B to D. Why? Because I have seen 2 strokes here, 2 strokes here. Dividing the shape like this gives me an isosceles triangle here, and gives me another isosceles triangle here. An isosceles triangle is a triangle where 2 sides are equal. So if you have a triangle like this, and this side are equal, this is an isosceles triangle. Isosceles triangle. Okay. Now this line and this line are equal. This line and this line are not equal. That's why this one has 2 strokes, this one has 1 stroke. For them to be equal, if it's 1 stroke, 1 stroke, it means they are equal. If I put 1 stroke here and 2 strokes here, it means they are not equal. Okay. To show that they are equal, the same number of strokes here should be the same number of strokes there. So if you have 1 here and 2 strokes here, then this is not an isosceles triangle. So now I have, because I have two strokes here, it means I can create 2 isosceles triangles. And if I create 2 isosceles triangles, already I can get this place, okay, because I can get this place, right? How? How do I get the place? I can get here by simply saying that, remember we're asked to find m. This is where I'm looking for. This is my target, m. Okay, so let me first find here. I will find here. When I find here, I'll also find here and here. Okay, so let me find here. How do I get here? This is a cyclic quadrilateral. And according to the theorem, opposite angles in a cyclic quadrilateral are supplementary, meaning this angle and this angle equals to 180. So equals to 180. So that means that 80, that is angle BCD, angle BCD, angle BCD plus angle BAD equals 180 degrees. Why? Supplementary angles. Supplementary angles. Now I know BCD. BCD is 80. Then what is BAD? Which is what I want to find now. So that means angle BAD, therefore, is 180 minus 80. This 80 goes over, it becomes minus 80. So angle BAD equals 100 degrees. So that tells me the angle here is 100 degree. Okay. Now, if I know this angle here, I can know this angle. And then I can know this angle. This is an isosceles triangle. This is an isosceles triangle. If you bring out this triangle, this is how it looks. Where here is 100. Where here is 100. And I don't know here and here. Now, what do we know about isosceles triangle? In every isosceles triangle, these two strokes tell you that this angle and this angle are equal. This angle and this angle are equal. So in this isosceles triangle, that means this angle and this angle are equal. So if I don't know what this angle is, so that means this A and B, it means if this is A, I can call here A as well. If this is B, I can call here B as well. So if here is 10, it means here also will be 10. Okay, so this, so now I'm going to find this angle here and then this angle here. Okay, now, so I'm going to say this angle, that is angle BAD plus angle ABD plus angle BDA equal to 180 degrees. Sum of angles in a triangle. Sum of angles in a triangle. Okay, now I know BAD. BAD is 100. So BAD is 100. So this is 100 plus, I know I don't know ABD. I don't know here. And I don't know ADB. So I don't know AD. I don't know BDA. And I also don't know ABD. So I don't know here and I don't also know here. But one thing I know is that ABD and BDA are the same, are equal, because this is an isosceles triangle. This angle is equal to this angle. So I can decide to use the same this thing for all of them, which means I can decide to say, call it 2 angle ABD, or I can say 2 angle BDA, or however you want to put it. But this means this and this are the same. So if you add up, it gives you 2 of it. Just like saying, if you have this is A and A times A plus A is 2A. So if these are the same, so let's just call it 2 angle ABD, okay, equal to 180. So if this goes to the other side, you have 2 angle ABD equals 180 minus 100. So 2 angle ABD equals 80. So divide here by 2, divide here by 2. 2 cancels 2. Angle ABD equals 40 degree. Remember, at this point, I can even say, at this point, I can say where angle ABD equals angle BDA. Okay, where this is equal to this. That's why I'm doing this. Okay, so now I know BAD. So ABD, rather, ABD. ABD, this is B. ABD is 40. So that means here is 40. Now remember, because this is an isosceles triangle, if here is 40, it means here is 40. So if here is 40, what that means is that ADB is also 40. Okay? So keep that aside. Now I'm going to go to the other isosceles triangle now and do the same thing so I can know what here is and also what here is. Okay? So I can do that. That's also another isosceles triangle. So I can say angle BCD. Angle BCD, okay, plus BDC. Angle BDC plus, this is BDC plus DBC. DBC all equals 180 degrees. Why? Sum of angles in a triangle. Okay, Now, but I know BCD. That means this one. I know BCD. BCD. So this is angle BCD. I know it. So that's it. That's 80. Okay. Plus BDC. BDC. I don't know it. See there. I don't know it. BDC. That's this angle here. BDC. BDC. The angle here. I don't know it. So I can bring down my angle BDC plus. And then you have DBC. 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 That's the angle here. I also don't know this angle. So I can bring down my angle DBC since I don't know it. All equals 180. So this can go over there. These two angles are the same. Why? Again, because this is an isosceles triangle. And in all isosceles triangle, since there are two strokes here, so the angle here always equals the angle here. So I can decide to use the same letters to represent them. Okay, so I can decide to call it 80 plus 2 angle BDC equals 180. So if this 80 goes to the other side, I have 2 angle BDC equals 180. If 80 goes over, you have 80 degrees. You have 80 degrees. Okay, so I will continue the calculation here. So at that point, I will divide. I have first 2 angle BDC. BDC equals 180 minus 80 gives you 100. So you have 100. So if I divide both sides by 2, 2 cancels 2, angle BDC equals 50. What that means is that BDC, that means this angle here is 50. And if this angle here is 50, it also means this angle here is 50. Are we there? So it also means BDC is 50. So it also means DBC. DBC is also 50 degrees because angle BDC equals angle DBC because reason isosceles. Okay, so at this point, I have found this side. Now remember, the question says determine the value of M. Determine the value of M. Where is our M? Our M is here. Our M is made up of this angle here and the angle here. And from here to here, that is here to here, it's the same thing. If here 40, here is 50, so our M is from here all the way to here. Therefore, our M is equal to 40 plus 50. 40 plus 50, which is equal to 90 degrees. So we have found the value of M using, so you see, we have been able to use both the theorem of supplementary sum of angles, opposite angles of a cyclic quadrilateral are supplementary. And then in this case, you see, we also made use of isosceles triangle as well. Okay, so our value of M is 90 degrees. Okay, thanks for listening. Make sure you subscribe to this channel for more questions on WAEC, on SAT, and IGCSE questions. Thank you.